guys, so we've just gone over the three types of irrational numbers. Let's do some examples. In these examples, we want to say if each number is rational or irrational and why. All right, again, if you want to turn off the video, try them yourself and then turn the video back on. I think that's a good way to do it. The first one, 2.125, that is a rational number. Why is that a rational number? Because it terminates. Terminating decimals can be written as fractions. That's what makes them rational. How about the second one, 2.111 repeating? That one is also rational. That one repeats. Could be written as 2.1 with a bar over it, right? The next one, 2.010110111. That one is irrational. That is one of those patterns that does not repeat, so you could not use a bar over top of it. The fourth one is rational. It also repeats. It would be 2.1234 with a bar over it. And the last one, also rational. It also repeats. The 3 repeats, so it'd be 1.083 with a bar over it. Hope you got those. All right, so the difference between rational and irrational, real quickly. Rational numbers can be written as fractions. Irrationals cannot be written as fractions. So when you see a decimal, rational numbers must be terminating or repeating. That's the only kind that can be written as fractions. Irrational numbers are non-terminating, non-repeating, and cannot be written as fractions. However now, numbers that are rational might belong to other groups also. These are groups I'm sure you're familiar with, but we're going to go over them real quickly as a review. We got 3 sets of numbers you can see on the screen. Natural numbers, whole numbers, and integers. Natural numbers are the numbers 1, 2, 3, and so on. The big thing is they do not include the number 0. Whole numbers include all of the natural numbers, but they also include the number 0. The only difference between whole numbers and natural numbers is the number 0. So whole numbers would be 0, 1, 2, 3, and so on. And the last set of numbers we talk about are integers. Integers include all the whole numbers and their opposites. Or you might say they include all the whole numbers and the negatives. So every whole number is an integer, but also the negatives. They go in both directions, all the positives and all the negatives. So if you take a look at a number like the number -2, -2 is just an integer, but it's also a rational number because I could write it as a fraction. You know, it's a terminating decimal. The number 0. 0 is not a natural number, but 0 is a whole number, and it is an integer. And since it's a terminating decimal, it's also a rational number. Remember, every number is either rational or irrational. And numbers that are rational might also belong to some of these groups. And that is going to be most of your job on the homework, is can you determine all of the groups that different numbers belong to? So I wrote, obviously a number can belong to more than one classification. That's a fancy word for groups. Below, we want to identify all the groups that each number belongs to by putting a check in the box of each category. And I put a hint there. You might want to simplify it first. Now, I would encourage you, go ahead and stop the video if you want and try to do it first yourself. and then start the video and see how you did. This is hard for most people to get these exactly right. Let me go over them. The square root of 100, I recognize right away that can be simplified. The square root of 100 is 10. So 10 is a natural number, it's a whole number, it's an integer, it's rational, and of course it's a real number. And why don't I get it out of the way right now? All these numbers are real numbers. Right? Every number we use in this class will be a real number. Maybe what we ought to go through is go through and check which ones are rational and which ones are irrational. Right? Because every number also belongs to one of those two sets. Every number is either rational or irrational. So let's see, which ones of these would be terminating decimals or repeating decimals? Well, this is a terminating decimal, so it's rational. The square root of 20, I typed that into my calculator and I found out that the square root of 20 is 4.7213, and that baby just keeps going. You know, 20 is not a perfect square. So the square root of it is a non-terminating, non-repeating decimal, better known as an irrational number. 12 over 7. Well, 12 over 7 is a fraction. That makes it rational, right? Rational numbers can be written as fractions. Negative 12. That's a terminating decimal. Negative 32 over 8. That is a fraction that can be reduced. It reduces to negative 4. A terminating decimal, therefore rational. 2.3 with a bar over it. 2.3 with a bar over it is a repeating decimal, so it's rational. And the number 13 is a terminating decimal, so it's rational. This whole group only had one irrational number. But our other job is to name what other groups the rationals belong to, right? The irrational number is done. Irrational numbers don't belong to any other groups. But rational numbers do. Let's see, 7.42. Well, you know what? Wait a minute. Here's an interesting thing. All three of these groups involve whole numbers or negative whole numbers. If I don't have a whole number, I'm not going to be in one of those groups. So a decimal is not going to be in one of those groups. A fraction, 12 over 7, that's not a whole number. Not going to be in one of those groups. But negative 12 is, that's a whole number. Well, it's a negative whole number. That makes it an integer. Negative 4 is also an integer, but it's not a whole number and it's not a natural number because those are only positive. A repeating decimal is none of them. And the number 13, that is a natural number, a whole number, and an integer. That is what the chart should look like. I hope you did well. Your homework will have several questions like those on it. Good luck.